Gorman,
And I'm Chance Sal.
and our project is called Water
Purification. The question was, does boiling water kill more bacteria than using evaporation traps? Filtering by t-shirt, live straw, solar power.
Yes.
I'm not sure how to do this.
So,
We had to leave that out because it was too expensive to do.
so for our hypothesis, it said if you're stranded from clean water, then you should boil the water because it kills the bacteria, viruses, and protozoans. Our variables are, so our independent variable is the different ways to purify the water. Our dependent variable is the amount of bacteria that is left in the water, and then our constant is how much water is already contaminated, or in other words, how much bacteria is already in the water.
Our materials were 3 gallons of pond water, 5 Q-tips, measuring tape, 5 auger plates, ruler, calculator, plastic zip-up bags, measuring cup, pot with lid, stove, timer, gloves and shovel, measuring tape and vegetation.
That's all. 4x4, plastic sheet, table, t-shirt, and computer. For our procedure, we first collected the 3 gallons of pond water, then we took it to the lab for some of the experiments. We used a Q-tip, dipped one end into the Q-tip, and then we had that end and swapped it on an auger plate. Then we let it grow for 24 hours. In the 24 hours, we'll observe and calculate how much bacteria colonies is in the sample. So you just count how many there are, and you record the data. Then we use a zip-up bag and put 8 cups of the pond water in it. We close it up, and in the morning place it where there'd be sunlight for the entire day. Then when you come back when the sun is set, and take it to the lab, and then get 1 Q-tip, dip it in, and then swap that end onto the auger plate. And then you let the auger plate sit there for 24 hours. Then you observe and calculate after the 24 hours. Then record the data.
Our data, the untreated water.
Yeah, it's very okay. So then we put on gloves to when we're using the stove, and we get a pot with the lid. Put 8 cups in the water. And
Dear high school Stuco, we will not be having a high school Stuco
the
meeting
water
today because
into
of
the
the
pot.
science fair. Thank you.
Then we'll place the pot with the water on the stove top, and then we let it boil for an hour. Then after the timer's done, we'll turn off the stove and let the water cool down. And once it's room temperature, then we'll take it to the lab and then dip 1 Q-tip in it, and then swap that end onto an auger plate and let it grow for 24 hours. After that, we record the data. Then we put on gloves while using a shovel for the evaporation traps. We actually didn't do it at the Prairie Farms. We changed it because weather, and so we did it in a garden, like our garden at our house. You dig a hole that is 2 feet wide and 2 feet long and 2 feet deep. Then you place some vegetation into the hole, and then 1 cup in the center of the hole. Then you get the 4x4 plastic sheet. Then you place it on top, putting dirt around it to hold it up. Then you dip 1 in the center, put a little dirt there so it stays down, so that when the water comes down, it drops into the cup. So then you leave it there and come back the next morning, and you can take off the plastic out the cup, and then take it to the lab, get a Q-tip, dip it in, and then swap that end onto the auger plate. In 24 hours, you calculate how much bacteria colonies are in there, then record the data. Now to the t-shirt. place a cup on a table, cover the cup with a t-shirt, then you pour, you get another cup, fill it with the, pond water, and you pour it through the t-shirt into the other cup. Then you take that cup and go to the lab, get one end of the Q-tip, dip it in, and swab it onto the agar plate and let it grow for 24 hours. Then record the data.
For the data, the untreated water that we had tested had 1,488 colonies in it. The filtered by t-shirt had 1,092 colonies in it. The live straw we had tested had 432 colonies.
The live straw was just for fun, pretty much, but we still decided to record it.
The solar power had 64 colonies, and the boiling the water had 112 colonies in it.
So,
When it was time for the science fair, me and Alex had no clue what we were gonna do. I was sitting at Mr. Adams' desk, waiting and talking to him about what I was gonna do for the science fair. I had figured, we had gone over this, and I was gonna do this one, and then Alex came over and asked Mr. Adams for help on getting a science fair project. So I asked him if he wanted to join me. At first we were having trouble, When we realized that both of us were having trouble, we decided to work together. We decided to try to solve the problem we might have. How to purify water. We got to lake. We got lake water and did 5 tests, but still I think my notes wrong. But still tested, got them, 6, oh, that's why. Sorry, 6, gee. We still tested 6 of them. The boiling disinfectant by solar power, evaporation traps, filtered by t-shirt, untreated water. We also did the live straw. That was for fun, as he said. But we decided to incorporate it into our data. We let the bacteria grow and counted how many bacteria colonies there were. Based on the number of colonies, we found which method works best.
So based on the data collected, we noticed that the live straw, it didn't do as well as we thought it would, filtering out the bacteria. The disinfection by solar power killed the most amount of bacteria, and the t-shirt filtered out the least, but we should know that filtering it through a t-shirt doesn't really work as good. So then, compared to the untreated, the t-shirt had close amounts. It doesn't look that close, but for how much it is, it's pretty close. And then the boiling did very well, just not as well as the solar power, and we didn't test the evaporation traps because it froze overnight. So now we know that it would work. You use evaporation traps during warm weather instead of cold weather.
So, are you guys done? Keep going, sorry. No, they're still going.
You're still going?
Yes, there was a break there and I.
Oh, okay.
So in conclusion, we discovered that disinfecting water with solar power works best. Our hypothesis was proven wrong. Even though boiling water worked well, it just wasn't good enough. In a life or death situation for water, we suggest that you use solar power, even though we had complications along the way. We figured it out, but there are still more ways to see if they work better there.
So for future decisions, if we do it again, I think that we would do more methods of purification and filtration, and test them both, do multiple tests for them and figure out the average of each method. We would start it earlier than we actually start the actual project, so we can do things that are, like you can use in warm weather, such as the evaporation traps. Any questions?